everyone! This is our science experiment and lesson about water pollution and oil spills. We are youth climate ambassadors from the Bay Area. Let's get started. Here is a table of contents. We'll be covering first water pollutions and oil spills, then real-world examples. Third will be the experiment, and then fourth will be some takeaways and key points. First, definitions. What is water pollution? Water pollution is the contamination of bodies of water with either waste, chemicals, or other particles that have a negative impact on the wildlife or natural life. Definition of oil spills. What are oil spills? Oil spills are the leakage of petroleum or any type of oil into a large body of water. Petroleum is often used for gas.
So some main contributors for water pollution are industries, wastewater, shipping, and plastic pollution. So industries are when factories release chemicals and waste into rivers and lakes, making them dirty and toxic for the environment around them. While wastewater comes from sinks, showers, and toilets. They go into treatment plants, however, sometimes they don't get cleaned enough and they enter bodies of water carrying pollution with them. Shipping is when large ships carrying oil and dumps can accidentally have a spillage in the ocean, harming aquatic animals and the water. While plastic pollution, as it sounds, is plastic waste such as plastic bottles and bags that can end up in the ocean, breaking down into tiny microplastics that threaten aquatic life. So what exactly are some main contributors to oil spills? So oil spills can occur more than from one source. Some sources are marine vessels, offshore drilling, pipeline leaks, and storage facilities. So marine vessels are accidents that involve ships and lead to oil spills into bodies of water. Offshore drilling are drilling operations that have accidents, whether it's from equipment malfunction or blowouts, which lead to the leakage of petroleum products and oil onto the environment. Pipeline leaks are oil pipelines that suddenly rupture or leak due to damage or improper maintenance, which lead to the leakage of petroleum products into the environment. Storage facilities are facilities that carry oil and they are dealt improperly, which can lead to the spillage of their products into the environment.
Oil spills often have lasting and negative impacts on water quality. Oil contains many harmful substances, which can disrupt aquatic systems. To begin with, oil spills can greatly affect seabirds and mammals. When in contact with their fur or feathers of these animals, the oil can destroy the insulating ability of their fur or feathers, causing them to come in contact with the cold water around them, which can lead to hypothermia. Additionally, the added weight inhibits birds' ability to fly, preventing birds from escaping predators and reaching their nests on land. Oil can also result in immune damage, lung, liver, and kidney damage, along with skin and eye irritation when ingested. Oil spills can impact fish. It can damage gills, hindering a fish's ability to properly breathe, and sometimes causing them to suffocate. Ingestion of these oils can also reduce growth, enlarge livers, and change heart functions, and prevent oxygen from being spread throughout the body. Fish eggs are also especially vulnerable to these oils and also die as a result. Oil spills not only damage wildlife, but plant life as well. In coastal trees, contact with oil can cause damage to roots, deform and stunt branch growth, and cause a loss of leaves, leaving forest floors exposed to the harsh sunlight, which leaves many creatures reliant on the damp environment to dehydrate. In coastal reefs, oil spills prevent proper growth and change the behavior of the coral, sometimes resulting in death depending on the amount of oil they are exposed to.
Where is this most commonly seen? Oil spills are most common in marine environments. However, they can also occur on land. Oil spills are dangerous for local ecosystems and have extensive consequences because of the loss of oil and the cleanup costs. In the picture to the right is boats attempting to clean up an oil spill. However, first they're trying to put out the fire on machinery that is most likely carrying oil. The Gulf of Mexico has seen the most oil spills in the world, with having 267 spills to this day. One of the worst cases ever seen of an oil spill was a Deepwater Horizon oil spill, also known as the BP oil spill. It was an oil spill in the Gulf of Mexico that lasted from April 20th to September 19th of 2010. That is 4 months, 4 weeks, and 2 days. It was considered the largest marine oil spill in the history of the petroleum industry, and after many failed attempts to contain the flow, the well was declared sealed on September 10, 2010. However, reports in early 2012 indicated that the well site was still leaking. On the right, on top, is a picture of the oil spill. You can see how massive it is. And on the bottom, it's an example of one of the effects of the oil spill, how it affects all the marine life and makes it inhabitable for them to live. Now, what is the experiment? Well, here you're going to be seeing what an oil spill looks like using a water bottle, water, dish soap, cooking oil, and food coloring. You will observe how oil spills happen and why it affects our oceans. For this experiment, you'll need 5 materials. First, a clear water bottle that's halfway filled with water of any temperature. Second, dish soap. You need 2 teaspoons of dish soap. Third, natural food coloring. You need any color of natural food coloring, just a few drops of it. Fourth, cooking oil. 2 tablespoons are needed for this. And lastly, measuring spoons. 2 measuring spoons so that you can measure out the teaspoons and the tablespoons.
For this experiment, you'll need a measuring spoon, cooking oil, natural food coloring, dish soap, and a clear water bottle halfway filled with water.
Here are some safety precautions to follow for the science experiment. Make sure an adult is present. Always be safe. Make sure to wash your hands before and after the experiment. Clean up immediately if anything spills. Observe each step closely. And lastly, follow directions. Now we're going to start the experiment. For step number 1, pour 1 tablespoon of oil into a clear water bottle that's halfway filled with water, as seen in the video. Step number 2. Observe the oil and the water for 2 minutes and discuss what you see. Because water is denser than oil, the liquids separate and the oil rises to the top. Step number 3. Add a few drops of natural food coloring inside the bottle and observe what happens next. Here we are using green food coloring. Step number 4. Finally, add 2 teaspoons of dish soap, which will act as an emulsifier to break down the oil and allow it to mix with the water. Notice how the coloring tints the water and the oil no longer rises to the top. Final result. Observe the uniform color in the end result. The oil no longer sits at the top.
So, some key takeaways and points from the experiment. First, we saw how the water, oil, and food coloring do not mix. This is because the molecules of the water cannot stick to the oil molecules, preventing them from mixing together. Next, we saw how the oil would not sink. Since oil has a lower density than water, it floats to the surface. Density is the amount of weight a substance has compared to its volume. Finally, once we added the dish soap, the oil, food coloring, and water all mixed together. This is because dish soap molecules are attracted to both water molecules and oil molecules, merging all three substances together and forming an emulsion. An emulsion is a combination of molecules that are not normally attracted together, which is what we saw in the experiment. So, well, how does this relate to oil spills? In the experiment, we saw how the oil always sat on top of the water, no matter how much it was mixed. This is similar to when wildlife get coated from oil in oil spills. They aren't able to rinse the oil off because the oil stays repelled from the water, and they are left to soak in the toxic liquid for hours or even days before rescuers can help wash them off with soap. Without the use of man-made chemicals and technology to remove oil from the ocean, oil can remain in an ecosystem for years, making it even more important that we as humans mitigate spills as much as possible.